So in this question, we've been asked to find the mean and the median of the following data sets. So our first data set has 5 values in it. And let's actually remind ourselves of how we calculate the mean. The mean is a value that represents the average of all of these numbers. To calculate that, we need to find the total, and we're going to divide that by the amount of values that we have. So first, let's start with the total. The total is what you get from adding up each of these values together. Now, you may or may not know the notation, but you are going to need to start using it. We use sigma x. Sigma is a Greek letter S. It stands for summation, or to sum, or to add things together. So this is the sum of all of the x values, the sum of all of the data points. This is not a 3 or an e, this is sigma x. Okay, so the total is the sum of all the x values. The total is sigma x, it's 35. The amount of values, we also have notation that we use here as well. For the amount, the frequency, the total, we use the letter n. N in statistics represents the amount or the number of something that we're interested in. So here, n is 5. The amount of values are 5. The mean, we can calculate that. At GCSE, you would have said the total divided by the amount. We're moving towards sigma x over n, and there we get an answer of 7. The mean of this data set is 7. To work with the median, we need these values in order. So let me just rewrite them in order. There's only 5 values, it's quite easy to put in order. And you might be familiar with this technique where you cross out values trying to locate the middle. This was an early GCSE technique, which once again we're going to want to replace. A more formal way to locate the median is to find the median position. And now this technique is going to work for any data set, no matter how many values there are. There might be 87 values in your data set. You definitely don't want to be crossing off values looking for the middle. N plus 1 divided by 2. This is the formula for the median position. However many values you have, add 1 and divide by 2, that will be the location of the median. We have 5 values. 5 plus 1 divided by 2 tells us the median is the third value. This is the superior technique, the more formal technique, and what we expect going forward. The third value is 7. Don't forget to identify that the median is 7. Okay, let's do something similar for the second data set. The total is going to be sum of x. Adding these numbers together, we get 42. N is going to be 7. There are 7 values. The average of these values, the mean of these values, sigma x over n, 42 over 7, the answer is 6. Let's locate the median. So once again, the median position is going to be n plus 1 divided by 2. That's 8 divided by 2. The fourth value is the median value. But they must be in order before we try to locate the median. Okay, the median in this case is the 6th value. In this question, we've been asked to calculate the mean and determine the interval that the median lies in for this grouped data set. Okay, so first thing to do, whenever you have grouped data and you're trying to determine the mean, you need to find the midpoint. We are working with the midpoint all the way through. So, midpoints are 45, 55, 65, 75, and 85. To calculate the mean, we're going to need the total and we're going to need the total frequency. The total is going to be calculated by multiplying each midpoint with its corresponding frequency. So the sum of FM, the sum of the frequency value multiplied by the midpoint value. So 45 times 2, 55 times 15, 65 times 19, 75 times 10, 85 times 1. Right, bringing all of that together, we get 2,985. When our total amount is coming from frequencies, we use sum of f as an equivalent to n. If we had to count some values, that would be n, but when we're calculating total frequency, we use sum of f. So n and sum of f serve the same purpose. The sum of f is going to be the total frequencies. All of those frequency values added together let us know there were 47 people measured. Okay, so the mean, a formula for the mean is now sum of FM divided by sum of F. Sigma FM divided by sigma F. The two values we just found, and they lead to a mean of 63.5. To determine the interval that the median lies in, we need to calculate the median position. What position does the median occupy? Well, how many values did we have altogether? We know we have 47. We can use n plus 1 divided by 2 to identify the median position and then determine which interval that median position is in. 47 plus 1 divided by 2, that tells us that the median position is going to be 24. Which group contains the 24th value? That is going to be the first group which has the cumulative frequency that is above 24. This group, 60 to 70, that includes the 20th value. The median is in this group, 60 to 70. In this question, we've been asked to draw a stem and leaf diagram for this dataset. Whenever we're drawing a stem and leaf diagram, it is a lot faster to do an unordered stem and leaf diagram and then one that is ordered. So, firstly, let's look at the stems. The possible stems will use the digits from the tens column. So, we have numbers in their 40s, 50s, 60s, 70s, nothing else beyond. So now I'm going to go for the list and I'm going to add in the leaves. I already have the stems, the number in the tens column. I'm going to add the leaf, the number in the units column. So 72, I'm just going to add the leaf of 2. 45, I'm going to add the leaf of 5. And so on. So 55, 71, 40, 59, 65, 52, 43, 79, 47, and 57. So there I have a very quickly produced unordered stem and leaf diagram. I only went through the list of numbers once. I didn't try to put them in order while I had the long list. But now, for each of these small groups, so for the 40s, 50s, 60s, and 70s, I can almost instantaneously put those in order. So now I'm going to do my ordered stem and leaf diagram. So the top row, 0357, 2579, 129. Very quickly ordering that stem and leaf diagram and avoiding any errors. As usual, we'll try and finish off with a key. This was always worth a mark at the GCSE exam. A 4 on the left and a 6 on the right represents the number 46. We do this to make it clear it wasn't 4.6 or 406 or any other numbers that use these digits. In this question, I've been asked to use the stem and leaf diagram to find the mode, the median, the mean, and the interquartile range. So lots of the statistics that we used at GCSE. So the mode is the most commonly occurring value. I'm going to look at each row and see if any of these digits appear more than once. In the first row, I have 2 4s. In the third row, I have 2 3s. So both of these represent numbers that occur twice. The numbers are not 4 and 3, the numbers are 94 and 113. So there are actually 2 modes, 94 and 113. Part B wants us to find the median. The median, we're going to use the formula to find the median position. How many values are we working with? We're working with 11 values. The median position, n plus 1 divided by 2, tells us the median is the 6th value. We already have all of our values in order. That's what a stem and leaf diagram does for us. So just reading through, the 6th value is 107. In part C, we're asked to find the mean. Now we know that the mean is the total divided by the amount, the sum of x divided by n. In this case, it's 1,177 divided by 11. The mean is 107. The mean and the median are the same value. There are certain instances in A-level maths where it will be important to recognize or spot that this has happened. Lastly, we're asked to find the interquartile range. Quartiles, the ones we're interested in, are the lower quartile and the upper quartile. Here's some more notation. The lower quartile is Q1, and it's 1/4 of the way through the data. So n plus 1 divided by 4. It's the value in the third position. Looking through this list, Q1 is 97. It's in the first row. The upper quartile is Q3. We'll refer to it as Q3. Its position is 3 times n plus 1 divided by 4. It's the 9th position, the value in the 9th position. You can count through the list, but here's a little trick. You can count 3 back from the end of the list, and you'll get to the same position. So the value in the 9th position is 113. The upper quartile is 113. The interquartile range, that's 113 minus the 97, which gives us 16. So an interquartile range of 16. In this question, we've been asked to find the mean and the median of the following data sets. So, to find the mean being an average value, we need to find the total. We've started to use this notation, sum of x, the total of all the x values. In this case, the sum of x is 106. We need to know the amount of values we're working with. We use the notation n. In this case, it's 4. The mean is the total divided by the amount. The mean is sigma x over n, the sum of x over n. 106 divided by 4 gets us 26.5. The mean for this data set, 26.5. To find the median, we need these values to be in order. So let's just rearrange them in order. It's only 4 values, quite easy to put them in order. And the median is going to be the middle value of these rearranged data points. We can see it's right here in the middle of 24 and 30, but more formally, we should be able to identify the median position. N plus 1 divided by 2 tells us the median is in the 2.5th position. This means it's in between the second and the third. It's the number exactly in the middle of the second and the third piece of data. In this case, we could add 24 and 30, divide by 2, and we get 27. The median is 27. In this second data set, we're going to do a similar thing. We need to find the total, the sum of the x values. We add those together, and we get 72. The amount of values that we're working with, the n value, we're going to get 10. The mean is the sum of x over n. 72 divided by 10, no calculator needed, 7.2. Let's locate the median. In this question, we're going to need to write the values out in order so we can identify where the median is and what its value is. So let's just write these out in order. As I put down each digit, I'm crossing them off from the original list. This helps me to know that I've got all of the values and I haven't missed anything. So here's the ordered list, which we'll work with from now on. And we anticipate that the median will be here, right at the middle, the point that splits the list in two. As always, we need to move towards a formal method. So the median position is going to be found using n plus 1 divided by 2. So that's 11 divided by 2, the 5.5th position. So in between the 5th and the 6th value. Since the 5th and the 6th value are both 8s, the midpoint of those two values is also 8. The median is 8. In this question, we've been asked to calculate the mean and to determine the interval that the median lies in for this dataset. I'm going to use x to represent these midpoints. So the midpoint of each of these intervals, I'm going to add in this space here. Whenever we're asked to calculate the mean from a grouped frequency table, we are going to need to make use of midpoints. So here they are. Let's use them to calculate the total. So the total, and we know the notation that we're now using, is going to be the sum of fx. Each of these x values multiplied by the frequency associated with it. X value times frequency, x value times frequency, etc. We'll take each of these x values and multiply them by the associated frequency. 130 times 2, 150 times 5, 170 times 18, 190 times 7. From that, we get a total of 5,400. This is the total. We also need to know the amount of values, the amount of year 10s that were involved. So we want the sum of f. The sum of f and n, they serve the same purpose. From a frequency table, naturally we're going to use the sum of f. 32 year 10s are involved. Okay, the mean is the total divided by the amount. The total divided by the amount. Sum of fx over sum of f. 5,400 divided by 32, and we get 168.75. That is the mean. To find the group the median lies in, I need to find the median position. We need to know how many values we're working with altogether. We already found a total frequency of 32. So the median position is going to come from 32 plus 1 divided by 2. 32 plus 1 divided by 2. That's the 16.5th position. That is going to happen in the third group. I know this because that is the first group whose cumulative frequency is above 16.5. Okay, so just to finish off with a sentence, the median lies in the interval 160 to 180.